In the previous video, we looked at unit testing. So unit testing is when we test individual functions or modules of a program. Right? And we saw various techniques like white box testing and black box testing, which can help us do unit testing. Now, in this video, we will look at integration testing and system testing. So what is integration testing? So after we have finished unit testing, that means we have tested each of the modules individually. Now we need to combine all of these modules or incrementally integrate these units and test after each step of the integration process. This is known as integration testing. So now let's look at integration testing in some more detail. So when should we do integration testing? So ideally it should be done when at least few or maybe even all the modules have undergone unit testing, right? So unit testing is done, that means that the individual units are working successfully, right? So now the objective of integration testing is to detect errors at the module interfaces, right? So where can the errors possibly occur? So hopefully errors within a module have been fixed because of unit testing. Now errors can occur when one module calls another module, right? So are there some errors maybe in parameter passing or in the communication between modules? That can be uncovered using integration testing. So let's take an example, right? So in this case, we see that there are modules M1, M2, M3, M4 and M5, and the arrows denote that the relationship between these modules, right? So for example, M1 depends on M2, M3 and M4. So some M1 calls some functions in M2, M3, M4, right? So if you, let's say we have unit tested M1, right? So module M1 has some non-local data and it calls functions of M2, M3 and M4, right? So now let's say we have successfully unit tested module M1, right? So we have created drivers and stubs for M1. And now we need to integrate it with the other modules, right? So what do you think are ways in which we can integrate this module M1, right? So let's reflect on this for a moment. And can you think of ways in which we can integrate M1 with the other modules? You can pause this video and think of ways in which we can do integration testing before proceeding. Okay, so now let's look at some approaches for doing integration testing, right? So one such approach is known as the Big Bang approach, right? So as the name suggests, right, all the modules are integrated in a single step, right? So all the modules which have been unit tested are linked together in one go and tested, right? And what is the issue with this? The problem is that it is difficult to localize or find which module has an error, right? So the error may lie in any one of these modules, right? And it can be expensive to fix, right? So hence this approach is meaningful only for small systems, right? And it is never used for large systems which have several modules. Another approach is the bottom-up approach, right? So a large software can have several subsystems, right? So the modules of each subsystem are integrated first in the bottom-up approach, right? So let's say we have M1, M2 and M3, right? Let's say they are one subsystem, and let's say M4 and M5 are another subsystem, right? Now, in the bottom-up approach, what we'll do is we'll integrate M1, M2 and M3 first, right? And we test and we do an integration testing. We then integrate M4, M5 and do an integration testing of M4 and M5, right? And then we incrementally combine all of these subsystems together, right? Now, in a pure bottom-up testing, it is not necessary to create stubs, right? Why is that? Because we are directly integrating all the relevant modules, right? So we need not create or mock the calling functions of these other modules, right? However, drivers are required, right? Because we need to simulate global variable calls, right? Many of these variables might not be available even in the subsystem, and hence drivers are required. Now, another approach, the converse, is the top-down approach, right? So what happens in the top-down approach? We start with the root module, right? The module at the top and some one or two subordinate modules of the root module, right? And these are suitable for software which have various hierarchical levels, right? So the top modules are tested first, then the modules at the next level are tested, and so on. For example, in this case, let's assume that M1 is at the top, right? M2, M3, M4 are in the next level, and M5 is at the bottommost level, right? So what will happen here is M1 is tested first, right? It is M1 undergoes unit testing, right? And then M2, M3, M4 are combined with M1 and tested. And finally, M5 is combined with all the other modules, right? Now, in a top-down approach, right, we do not require drivers, right? Because we start from the top, so hence all the relevant global variables are available, right, at each stage. However, we need to design stubs, right? Because at each level, we do not know, or if this module requires some other modules at a lower level, right? We need to simulate them or mock those function calls. Hence, stubs are required, right? So, for example, when we combine M2, M3, M4, we need a stub which simulates M5. So that is the top-down approach. And finally, we have a mixed approach, right, which uses both top-down and bottom-up testing. So in this case, integration testing happens as and when the modules become available, right? So this is a combination of both bottom-up and top-down approach, and we do it when the modules become available after unit testing. Now that we have seen the different types of integration testing, finally we do system testing, right, where the fully integrated system is tested. Now there are various ways in which we can do system testing. So one way is to define who is going to test the system, right, based on who is doing the testing. So for example, we saw these types of testing, right? So alpha testing is done by a test team within the organization, whereas beta testing is done by a select group of customers outside the organization. And then we have acceptance testing, where the system is given to the customer and the customer determines whether the system satisfies the requirements or the user stories, and they decide whether to accept the delivery of the software or not. Now there are other types of system testing as well. So let's look at some of them. So one is known as smoke testing. So what is smoke testing? So in smoke testing, firstly it is carried out before the initial system testing, right? So before sending it out to the for alpha testing or beta testing, right, we do smoke testing. So basically we just check whether the basic functionalities are working, right? So a few basic test cases are designed and they are checked to see whether the basic functionalities are working, right? So for example, in case of the seller portal, basic functionalities like add products, let's say you want to add things to the catalog or to the inventory. So are these basic functionalities working? That can be done using smoke testing. Another type of testing is performance testing, right? So in performance testing, we check whether the system meets the non-functional requirements. So up till now, in the unit tests and the integration tests, we were looking at whether the system satisfies the functional requirements, right? So whether the functionalities are being met by the design system, but we also need to check for non-functional requirements as well. So for example, one type of performance testing is stress testing, right? For example, the volume of input data, the processing time, the memory, all of these are tested beyond the design capacity, right? It is used to check for the reliability, the robustness of a given software, right? For example, we might simulate several transactions to the database, right, beyond the expected capacity. So how does the database, or how does the system deal with such, high volumes? And this performance and stress testing and all is done to check for the performance, reliability, robustness, all the non-functional requirements.